Hey there. So this video is going to address the structural model for repeated measures, the structural model for repeated measures. So let's go ahead and dig into that. So here I'm on page 460 of Howell, and there are two different little structural models he gives, and I'm going to focus on the second one here, and even he says this is probably the more realistic of the two. But basically a person's score is a function of the grand mean plus, then you have pi. Pi is this idea of individual subject differences, etc. This is the thing we're kind of pulling aside in the model, putting out to the side. And then what we have left, we have tau, which is this idea of treatment effects. And then, so that tau is something that we saw in the one-way ANOVA structural model. And then we have the interaction between individual subject effects and the treatment. And this is the thing that functions as our error term for the F ratio. And I'll show you that in just a second. And then we just have whatever's left over, which is just referred to as error. So basically, again, a person's score is a function of the grand mean plus this idea of individual subject differences plus treatment effects, right? Plus, and that's going to be the error term essentially for F ratio, pi times tau, and then plus whatever's left over for the error. If I go back to this repeated measures primer, you can see those effects are floating around here. This would be, so again, this is the repeated measures primer. Here you have variation between subjects, so this is going to be pi, this is going to be tau, and this is pi times tau. All right, so that's how all this kind of breaks out. All right, so so that's just another way to visualize this. So a person's score is a function of the grand mean plus variation between subjects, okay, plus then something with tau, which are treatment differences, and then the subject by treatment interaction, which ends up being the error term. And how does this compare to a regular one-way ANOVA? Well, remember, a one-way ANOVA basically just had a person's score as a function of mu plus tau, which is treatment effects, then plus error term. So that's our regular one-way ANOVA.